All right, so we're going to actually get into creating the unit circle right now. But before I get in and dive in and creating the unit circle, I want to talk about the symmetry of a rectangle inscribed in a circle. So let's say we have a circle right here, and we're going to go ahead and put in an X and Y axis. And I'm going to pick a point right here in quadrant 1, and I'm going to call this point X, comma, Y. And I'm going to inscribe a rectangle inside this circle, and we're going to try to figure out what this point is, what this point is, and what this point is. Well, what's really nice about circles and rectangles, they've got a lot of symmetry. I know that these two sides of the rectangle are going to be congruent, and I know that these two sides are going to be congruent. So if I look here, if I come and I move over this direction, well, I'm only affecting the X, so I know that this Y is going to stay the same. Well, what's really nice is this length and this length, this is going to bisect it, are going to be congruent. So this X is going to be equal distance from the origin, so this becomes negative X. So this point here, we kind of do the same trick. Here, my X's stay the same, but my Y's are going to change. So this point's going to become negative X, negative Y. And then if I come over here, once again, my X's are changing, but my Y's are staying the same. So I've got a negative Y, but my X's change, so I have an X. Same idea here, my X's don't change, but my Y's do change. So if I know this one point and we inscribe a rectangle in there, I know these other 3 points. Now also, if I drew an angle in standard position, and that was horrible, to that point, and we call this theta. So in quadrant 1, if I have an angle which is theta. Now if I start drawing in these diagonals to a rectangle, well, if I need to calculate the angle for each of these in standard position, well, I have my theta. In quadrant 2, I want to be drawing from here to here. Well, that's going to be theta plus something else. So if I know this angle right here, I could actually just subtract. Well, these angles are congruent. This is also theta right there. So this ends up being, for quadrant 2, a 180 degrees minus my theta. And in quadrant 3, kind of the same trick. If I kind of go from here to here, now this is also a theta. So this would be 180 degrees plus theta. And then if I do quadrant 4, we go right here. Well, this is also another theta, but it's a negative. So in quadrant 4, I can actually do 360 degrees minus theta. So I can actually find all these angles. So let's take an example and see if we can find the angles at which the diagonals of this rectangle are. So let's say if this theta was 45 degrees. So in quadrant 1, I'm going to tell you it's 45 degrees in standard position. So we're going to look for quadrant 2. All I'm going to do is take this 45 degrees and do 180 minus 45. So quadrant 2 is going to be 180 degrees minus 45 degrees, which gives me 135 degrees. In quadrant 3, we're doing 180 plus my angle from quadrant 1 is 180 degrees plus 45 degrees, which gives me 225 degrees, and these angles are all in standard position. And then in quadrant 4, 360 degrees minus the angle. So 360 degrees minus my 45 degrees, this gives me 315 degrees. So we're going to need, I'm going to use this idea to help build the unit circles so we don't have to do the same action over and over and over again. So the symmetries are important, and you will see these formulas later on in pre-cal as we get really rolling through the content as we start actually solving trig stuff. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.